Well, this one's very different. You can square both sides right now. Let me show you what happens sometimes. It's not so common, just because all of this is kind of weird. But some students are like, hey, I'm going to square both sides right here. Watch this. I get 4x minus 3 minus 3x minus 5 equals 1, and then they solve that.
Something tells me that's not right.
That's not right. That is absolutely,
It'd be too easy.
math people, right, it's too easy. It's a great way to put it.
We need to be more miserable.
We've got to, well, it's mental abuse to humans, so we should expect a little bit at least. So here's what we got to do, all right, is you can do that. It makes things super complicated, which I don't mind because I'm a math guy. But we're trying to make it as least complicated for class as we can. So what I'm going to do actually is I'm going to get rid of this square root of 3x minus 5. I'm going to put them on separate sides because if I keep them on the same side, it's going to overcomplicate things, which I don't really want to go through. It can be done. It just sucks.
So we're just gonna add a square root of 3x minus 5?
That's it. Add square root of 3x minus 5. Add the square root of 3x minus 5 on both sides, right? And that's a principle of equality, so it's okay to do that. And again, the reason I'm doing this is to get square roots on opposite sides of the equal sign, okay? So what does that do? It zeroed out that part, which is what we wanted. Now I can drop my square root of 4x minus 3 on the left, and then on the right I've got 1 plus the square root of 3x minus 5. All right. Now, you may not believe that made things easier for us by the time I finish. You don't have to believe it, but it should. Okay, so now what I'm going to do is I'm going to take both sides and square them. Okay, now on the left, it does get rid of that square root, right? Because I've got the square root of something to the power of 2.
I have a second binomial.
Oh, yeah, no, it is pretty ugly. So we gotta work with that sucker right there. Now I'm gonna do the work on this, I hope. So I'm gonna rewrite this. So I got 1 plus the square root of 3x minus 5. Let's make that a little bigger. But I'm multiplying it by itself, okay? Now again, a common mistake here is where students are like, oh, 1 squared plus this, 1 plus this, and then it's done. No, it's a binomial now. So you got two terms, you have to show it as two binomials that are being multiplied by each other. And that's what makes it so fun. So now I'm gonna use some distribution, or some people like to call FOIL. So 1 times 1 there, and then 1 times the square root, positive square root of 3x minus 5, so plus, I'll just make it the square root of 3x minus 5. And then this one as well is square root of 3x minus 5 times 1, which is another square root of 3x minus 5. And then finally, I've got the square root of 3x minus 5 times the square root of 3x minus 5, which is, yeah, it's just 3x minus 5. Now, to clarify that that's where that came from, I will put that in parentheses. But I'm not going to below, okay? Now that I have that, I can start combining some like terms, right? So I've got my constant 1, and then way over here I got this negative 5. 1 minus 5 there would be 4. Yeah, negative 4, thank you. And then I've got, I'll do these square roots next. So I've got the square root of 3x minus 5, but I got 2 of them, right? Because I got 2 of those, so that I'd have positive 2 of those. And then also we've got this 3x that just drops, positive 3x. Wow, that's great. We're almost there.
Where did you get the negative 4?
All right, now we have another square root in an equation. So I'm gonna have to isolate that sucker. So let's do that. Let's start by using a principle of equality, right? So anything added or subtracted, I'm going to zero out. So the minus 4, the negative 4 right there, I'm going to add 4 to both sides to zero that out, and it will. But negative 3 plus 4 is, well, positive 1. But also the 3x on the right there in orange, I can zero that out as well. So minus 3x's from both sides. I'm just gonna show that as x. 4x's minus 3x is just x. You could put 1x if you want. But this now equals the square root part of that, which is not just the square root, but it's 2 times the square root of 3x minus 5. All right. As much in my heart as I want to get rid of that 2, I'm not going to. I'm not going to. Because, and specifically because I don't want to deal with fractions, right? Because if you divide by 2 right here and here, then you get a 1/2 x and then 1/2. And we're going to deal with a binomial that we've got to square. So I don't want to do that garbage. But what I would like to do is just square both sides at this point. We can do that, absolutely. It's the principle of equality. It's just, so let's focus first on the left side, and then we'll get to the right side, which is full of excitement. But now I got x plus 1 times x plus 1, which would be, I'd have x squared there, and then positive 1x, then another positive 1x, and a positive 1 right there. It's all multiplication, that's what distribution is. Then I can combine my x's to get 2x's. Now I got x squared plus 2x plus 1. So that simplifies the left side completely. And this would equal the right side squared as well. Now, you're squaring both parts, right? So it's really just 2 squared, which would be 4. Now you got a square root, multiply, let me rephrase that. You're going to square the square root of 3x minus 5, which would have just been 3x minus 5. Now, at this point, I'm going to distribute the 4, because that seems like it'd be fun. And 4 times 3x's would be 12x's, and 4 times negative 5 would be negative 20. Now, we've finally gotten rid of all of the square roots. As fun as it was. I still have an equation to solve, though. So let's get rid of, again, I've got a trinomial on the left, which means I would like it to equal 0 and see if we can factor some stuff out. So let's minus 12x's first from both sides. So 2x's minus 12x's would be negative 10x's. And then we'll add 20 to both sides to zero out the negative 20 as well. So plus 21. And again, that zeroes everything else out on the right side, but I've got to drop my x squared as well. Well, hey, I've got a trinomial that equals 0. Can it be factored? Well, if we should expect these to be factored pretty nicely.
7 and 3.
Yeah, it's, well, not just 7 and 3, it's negative 7 and negative 3. Oh, you've gone beyond, yes. I apologize. Yes, so now I've got x's, right? And then I've got a negative 7 and then a negative 3, which is going to equal 0. And as much as you don't want to see this work, here it is. So if I can get x minus 7 to equal 0, that'd be good. Solving this, I would add 7 to both sides. And I get x equals 7. But also, if I could get x minus 3 to equal 0, that'd be good too. Just add 3 to both sides. And yeah, this work, not every student needs to show that work. But if you want to, that's fine. It's just not required, because if you understand it, that's fine. Besides, there's plenty of work here to look at. And if you got colored pencils like I do, it's pretty. But I've got two answers to check now, right? So I gotta, let's go back and then get this entered into the original equation twice. All right, so I'll try 7 first in this first one. Okay, so let's replace that, both x's. That's 7 there.
Oh, they are. They both are.
It's gonna work, huh? All right. Yeah, right here you get 1 equals 1, and that was a question mark. Now that's true. So we know 7 works. And the other one we had was x equals 3, so replace x with 3. Again, all this stuff I'm highly recommending you just put in the calculator. If you do it by hand, you know, like right here, 4 times 3 is 12, minus 3 is 9, square root of 9 is 3. Right here you got 9 minus 5, which is 4, square root of 4 is 2, 3 minus 2 is 1, 1 equals 1, that's true. Got my question mark there. But again, that just confirms that we did in fact find the solution.